when we started the section on parabolas, we talked about how you get a parabola, remember? And that was all the points that was equidistant from the focus and the directrix. Well, suppose I have 1 point here. Okay? And I said to draw another point, so we'll call this C, to draw a point 3 units away from C, right? So that would be right there. And now suppose I said draw another point 3 units away from C. And now I said draw another point 3 units away from C, and another point 3 units away from C, and another point 3 units away from C. And if I draw every single point that is 3 units away from C, what shape do I map out? A circle. Okay, so that's what a circle is. A circle is the set of all points that is the same distance away from a given point C. Okay? That point from which all of these other points are equally far away or equidistant is called the center. And the distance, right, of each distance, so the distance of this, the distance of that, the distance of that, so the distance that each of these points is away from the center is called the radius. All right, all things you know, but now we're just putting it in a different context. Now, the equation for a circle is this: x minus h squared, y minus k squared equals r squared. So you see it's got a lot of the same elements as the equation of the parabola, right? What was the equation of the parabola? Let's write it up here. It was y equals a x minus h squared plus k, right? So you see there are some similarities. You've got the x minus h squared. One difference is, in the case of the parabola, how many of the variables are being squared? 1. In the case of the circle, how many of the variables are being squared? Both variables are being squared, right? So how do you, if you're walking down the street and you see an equation on a billboard, how do you know if it's the equation of a circle? Well, the x variable has to be squared. The y variable has to be squared. There has to be a plus in the middle. And here's the deal breaker now. The coefficients here and here have to be the same number. So either 1, 1, 3, 3, 9, 9, 7, 7. Okay? That's how you know it's a circle. So for example, would this be an equation of a circle? No. Already you see that it fails. Okay? Because this is a coefficient of 7 and that's a coefficient of 1. So that doesn't work.
They have to be the same?
They have to be the same coefficient. That's how you make it a circle.
Isn't a circle just 2 parabolas?
No.
It's
not 2 parabolas. It's 2 semicircles, but not 2 parabolas. Because a parabola doesn't...
It'd be like a
yeah,
egg.
it would be something else. Okay. Now, this number, this is r squared, and it's just the radius squared. So from here, we can easily extract the center, it's h and k, and the radius is just the square root of that last number. Okay, so let's come up with an equation for this circle. I have the center, which is h and k, and I have my radius. So it's going to be x minus 0 squared. Yeah, that's just x squared. I'm going to write it like this one time, and then we don't have to write it in this much detail anymore. Plus y minus 3 squared is equal to what? 7 squared. So finally, x squared plus y minus 3 squared is equal to 49. Yes, we have to simplify because we're now in March of our Algebra 2 year, right? And we can do this. Yeah.
Can you root it all to get rid of the...
No, absolutely not. Okay? Okay, so in the next case,
What happened to the 0?
well, what's
Just
x
go-
minus?
it's
Okay,
0.
so in the next case, again, I'm only going to write it this one time. X minus 0 squared plus y minus 0 squared is equal to 0.25 squared. So that's x squared plus y squared is equal to, how much is 0.25 squared these days?
Point.
0.625, thank you.
Did you know that already?
Mm-hmm.
Or does that sound just sound right?
No, it's, well, 25 squared is 625, right?
Right.
Yes, okay. All right, so what does this tell me? If a center, where is the center of the circle? 0, 0, which is the origin, right? If a circle is centered at the origin, then the equation just looks like x squared plus y squared. Okay, that means it's centered at the origin. All right. Here, let's write an equation for this one. Where is the center of this? 0, 0. Now, how big is the radius? Is it? So we know that the radius is this line connecting 0, 0 to 1, 5. Is there any way we could possibly find the distance? Distance formula, man. Okay. So the radius is going to be the square root of 0 minus 1 squared plus 0 minus 5 squared. Or you could do 1 minus 0 squared, 5. It's the same. So basically the radius is the square root of 1 plus 25, the square root of 26. Now, don't plug it in your calculators. Don't try to simplify this, because when you put it in the formula, what are you going to do to the radius?
Square.
You're going to square it, so it's all going to go away. So quickly, what's the equation for this going to look like? Right, and x minus 0 squared we know is just x squared plus y squared equals 26. Well, okay, so let me add one more step. Root 26 squared. X squared plus y squared is 26. Isn't that fun? Right? It's just amazing. Okay, so here's another one. Now we're given the equation. We need to find the center and the radius. So first one, where's the center? 0, 0. What's the radius?
12.
12, because it's the square
Wait, why
root of
is
that
it 12?
number. Because it's the square root of 144.
I don't know why I said that. That's 12.
Because your brain reasoned that it's the square root of this number.
Oh, okay.
This number is r squared, so the square root of that number is 12. So I always tell you guys, when you come ask me questions during the test, am I doing this right? I always go, trust your gut. You gotta trust your gut, right? Okay. All right, so what about the next one? What's their center? 3 and negative 7, nice. And what's the radius? What's the radius? What's the radius? The square root of 50. Now, for this, I would like you to write it in both ways, both in a simplified root form or and decimal. So in simplified root form, how much is this? 5 root 2, exactly. So 50 is 25 times 2, which is 5 root 2. How much is it in decimal? To one decimal place. 7 what? Nice, thank you. Okay, so look, 5 root 2 is exact form. It's exactly 5 root 2. When we plug it in the calculator and we approximate the decimal and we round, we use these squigglies, meaning it's approximately 7.1. Okay, so just a little bit more elegance added to our math language here. Yeah.
Why is it positive?
Because this gives you the x value. But remember, you have to take the opposite sign. and this gives you the y value, and you have to take the opposite. These are h and k. Remember, it's x minus h and y minus k? Right? Okay. Here, well, this is a mess.
Is that finished? Do we not have to put it into the...
It's done. We started with the equation, remember?
Oh, right.
Yeah. Okay. This is a mess, but we now have to complete the square. And guess what? We have to do completing the square twice in the same problem. We have to do it for the x's, we have to do it for the y's. So here's what we do. The term that's a constant, no variables, that's a loner. He just stays off to the side. We have to group all the terms with the x's and group all the terms with the y's. It just so happens that there's only one term with the x's, so we'll just let that hang on its own for a little bit. Plus, where are my y terms? Here. So I'm going to group them in their own house, y squared minus 6y, plus a number, minus 16, minus a number. Okay?
How do you find that number again? Do you divide 6 by 2?
Equals 0. Yes.
Wait, what, divide what by 2? You divide 6 by 2.
Okay, so now, we're going to divide 6 by 2 and squared, and we're going to get 9 and 9. So now I get x squared plus, can I factor this? Y minus 3 squared minus, how much is that? 25.
Wait, why did it become y minus 3 squared?
Equal to 0. Well, this is how we factor when we complete the square, right? You take the square root of the first. Right. Okay. Now we need to make this look like an equation of the circle. So where is the 25 going to have to go? To the other side. So x squared plus y minus 3 squared is equal to 25. And oh my God, guys, look at what we did. We wrote an equation of a circle in standard form, right? Now, can I extract from this the center? 0 and positive 3. We take the opposite sign. How big is the radius?
25.
5. It's the square root.
Oh.
You knew that, right? Okay. Let's do this next one then.
I think we have to do it twice.
Well, for this one, x happened to be alone, so we got away with one time, but we're not going to be so lucky in this case. Okay, so let's group the x's together. So it's x squared plus 9x plus a number. Now let's group the y's together. Y squared minus 8y plus a number. Now, you could either leave the 4 on this side or take it over from now. What do you want to do? Leave it? Take it over. When you take it over, then you have to do plus the red number plus the blue number.
Negative 4?
Okay. Yes, it's negative 4. I'm sorry. So, if you kept the 4 on this side of the equation, on the left side of the equation, then you subtract these terms. But if you put it here, then you add the terms, okay?
When do you subtract?
When the 4 stays on the left side. Like you see?
Oh, okay.
Okay. So, what number goes in the red blank?
Is it typically easier to move it over in advance?
Yeah.
Just because it's more organized?
What number goes in the left blank? Red blank.
9? Oh, no.
9. 9.
Wait, why did you do that wrong? Wouldn't you divide 9 by 2?
Oh, sorry.
4.5?
Sorry, yeah, it's 9 over 2 squared, so it's 81 over 4.
Wait.
And what goes in the blue? So 81 over 4 over here as well. What goes in the blue? 16. 16. Okay, so let's factor the red. It's going to be x plus what quantity squared? 9 over 2 plus what squared here? Y plus or minus? Minus 4 squared equals, look what I have here. I have the negative 4 plus the 16 gives me 12. Is that right? 12 plus 81 over 4. Here's how I do my loop. 4 times 12, 48, plus 81 is what? 129 over 4.
Wait, can you repeat that?
Yeah. So this is the equation of the circle now. What's the center? And what's the radius? It's the square root of 129 over the square root of 4, which is the square root of 129 over 2. And does 129
No.
simplify? No. All right? In decimal, how much would it be? It's 5.7.
Wait,
Okay.
Did you just simplify a radical with your calculator?
No. So I tried 129 divided by 3. That gives you 43, which doesn't simplify anymore.
Oh,
Okay. Last but not least, find the equation of the circle given the end points of the diameter. Okay, so now this is a little bit trickier. The end points of the diameter. So let's plot this first. 1 is at negative 2 comma 6 here. And then I have one at 8 and 14. Oh, okay. Let's relabel this. Yes, look at you guys.
Wouldn't that just be midpoint?
Negative 2, hang on, negative 2 and 2, 4, 6. That's one end. And then 8 and 14. So 8 and 14 is the other. Okay? Somewhere in the middle here is a center, and the circle looks like this. Okay? This is the diameter of the circle.
The midpoint is the center.
So the midpoint, so the center is the midpoint. All right, so let's find the center then, or the midpoint. So how am I going to find the center? What am I going to do? So what plus what over what? 8 plus negative 2 over 2 and 14 plus 6 over 2. Okay? So 8 minus 2 is 6 over 2. So this is 3 and 10. Okay? Man, I was pretty close there. Okay? So 3 and 10, that's the center. Okay, what else do I need? The radius. How am I going to find the radius? Distance formula. So distance between what? There are two things I could do. Right, so I could either find the distance between the center and one of the endpoints, or I could find the distance between the two endpoints and cut it in half, divided by 2. So let's just do the first part. Let's do the distance between center and one of the endpoints. I'm going to use the left endpoint, so I'm going to call this x1, y1, x2, y2. So for the radius, it's going to be the square root of x2 minus x1, 3 plus 2 squared, plus 10 minus 6 squared, 25 plus, well, how much is that? 16? So that's root 41, right? Yes? Okay, now what's the equation then? X minus what? Squared. x minus 3 squared plus what? Y minus 10 squared equals how much? Root 41 squared, which is just 41. Okay? So there you have it.
You don't ever have to think about your y. You don't have to think about your like other numbers when you're doing the equation. Like you only put x2. Wait, yeah, you only put x2 and y2, so you don't have to worry about the 1. Yeah. Like -2, -6. You know, put it in.
Oh,